open that document. I should have actually had it in my in yeah. Yeah, so sorry, I don't have a second monitor right now, so I can't see both the screens. So if you have any questions, please shout out. That would be ideal. Um, yeah, so as kind of we discussed earlier, also, right? We are trying to do the machine learning on Kubernetes in this particular series, and we kind of chosen the book which is available here on PactPub. So a part of this book basically um, kind of explains all the content, all the stuff what is happening in the background, machine learning, MLOps, and so on. But as we could not follow the book as it is because of the hands-on, so we thought of trying it out on our own way, kind of building our own flow. But eventually, we'll kind of connect all the dots, what we are doing, and then what this book talks about, and eventually, whatever the example they have mentioned, we'll run it maybe in a few sessions after today, right? So what we have done earlier is we talked about MLOps overview, and then we touched upon the what is machine learning, and we saw also what is Jupyter notebooks and how to use them to do the basic ML stuff. So Jupyter notebook is nothing but interactive Python. You can do more than, of course, machine learning things on top of it. But we saw last time how we can set up Jupyter Hub on Kubernetes, and then how we can spin off one of the instance of it, and then run some Python code on that. So for the people who are new for the first time, I'll do a quick recap. So I was building a slide deck for myself, and then I'll quickly go over it, maximum 2-3 minutes, and then we'll connect with the flow what where we are last time, right? So we'll just do that. So let me just present the screen. Hope you can see it. Yeah. No, I don't think you can see my screen yet.
Mm-mm.
Not yet.
Yep. Let me share my screen. Okay. Yeah. Yeah. So this is the flow which we discussed earlier, and then this link is available on the Slack channel. We can post again. That is what I talked about earlier. So I'll quickly go over the slide deck for the people who are new. I'll just quickly run through it once so that we're on the common ground. Yeah, so assuming that, so what is machine learning in general? So from a practical perspective, let's say you're trying to find out an apartment to stay in. I could take an example of Bangalore here. And as I can see on the screen, there are different prices for different, I mean, three-bedroom apartments at different locations and so on, right? So now I want to look by the apartment, and then I see this kind of pricing on my screen. Now I would, of course, kind of look at why the 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 price differs so much. And of course, we know that, right? All of the real estate would be based on locations, distance, who's building it, and all those things. This is the kind of pricing what I can see. And these, what you see here, right? This is the apartment. This is the feature we can say, right? So these are features. Based on those features, we get some pricing at the end of it, right? So that is what is happening is we have a data. With the data, we know what are the different locations, distance, and all those things. And based on that, we can see that this is the pricing what we can get at a given location, or where we should kind of go and buy. So of course, as an expert, we can look at this data which is available to us, and we can say that, okay, if I have this budget, I should go and look at this area. But what we can also do is, rather than every time going somebody looking into the data and showing it, if we can build some kind of a machine learning, some kind of algorithm, right, which can predict the data based on my request. So for example, if I say on the UI, if I say I want to buy an apartment at this location in Bangalore, it can tell you how much budget you should have, kind of a thing, right? So we can replace our expert within machine learning, and then eventually what we'll get is we can build a model, and that model can help us predict. So what's happening here, as you can see here, these are features, and with the features we know what are the pricing. This is the real data what we have from the internet or from our survey. So This is the data which we should be getting ahead of time, and from the data we can build a model. This is a model is being built. Now next time if somebody comes and give me a new request, right, for a given location or whatever, right, I can look at my model and predict the next pricing. That is how the machine learning at a high level works. Now there are different kind of machine learning algorithms, which machine learning algorithm categories are there through which we can build models. So we saw the example of supervised learning. What we have in this case is we have label data. Now what is the label data? This is what we see that, right? We have a given feature given specifically, and we know that what difference does it make. So for example, if I say that okay, if my apartment is 80 kilometers from the airport, we know that the price of the apartment is going to come down, correct? So that is what I can kind of call a label data through which I can predict something. Then we have unsupervised learning, through which basically we don't have a label data. Our algorithm should be able to kind of find some kind of pattern and group them or something like that it can do. And the last one we have is a reinforcement learning. So what's happening in this case is we have an agent, which is an ML agent or AI agent, whatever. We kind of give it some task, and then we reward it if it does the right stuff. So this is, let's say me, I'm watching, and in my environment, if the robot does something, I'll kind of give it reward if it is the right step. That is how somebody would learn. If I perform the steps again and again, and if it is good, it is going to basically um, go forward. So that's how the kids would learn, right? Like if you fall down and then you again stand up and then kind of walk and so on. That's what this particular learning, R learning, is all about. So again, very brief of it. So what we saw, the example of last time is a supervised learning, and this is not the ML class or whatever. So we're not going to go with the ML details, but let's come back to ML on Kubernetes. So what we saw last time is an example in which we took an example of similar the house pricing, right? Let me try to get that particular data set. Um, oh yeah, I think this repo we have used last time, regression. So we'll now build on the previous sessions, what we have done. Any questions if you have? Okay, so what we saw last time is that some basically we have some data. Like in this case, we know that square feet of our house and what is the actual pricing of it, right? So that is the example what we saw last time, that we got some data. Through the data, we have trained our model. Now, what does training a model means? That you basically have, like in this case, we are going to take an algorithm of machine learning and then try to see if that algorithm can fit my data which I have, right? Like in this case, we are doing with the linear regression. So what we do is we kind of import this algorithm from a scikit-learn module, and then we say that okay, this is my data, right? X and Y. So X is nothing but your input. What is you're giving it this particular array, and Y is the second one. This is the actual pricing. This is what we saw on the table here, right? So if we pick up this algorithm and then try to kind of say, okay, use this algorithm to fit this data, what I have, and as it does, you can see it kind of follows this line here. And now we can see that this is the best possible way by which this line can be formed. So again, there are multiple steps involved in the process of doing the linear regression, like doing the model fitting here. But I'll not go into that. What happens eventually is we get this kind of line here, which optimally fits my data. Now, let's say if I predict, or if I want to have the size, if I want to have the pricing of, let's say, 225 square feet, or what, let's say 575 square feet house kind of a thing, right? If I apply this particular model, it can reply back based on this regression, what it has built, right? So like in this case, The example they have given here is I am predicting the size of 3000 square feet, and it not sorry, it's a range, but I can pick up like this one, right? So, for example, I'm predicting for 750, and it tells me the predicted price is 214. So that is how it's going to kind of work out. So, in general, is that you have built an algorithm, and if you give some input to it, you give a prediction out of it, right? That's what at a very high level. Make sense? Okay. Any questions? Okay, fine.
No, this makes sense. This is what we talked about last week. This
Yeah,
makes
correct.
sense.
Yeah. So now what the next part is, we were discussing about now how to take this forward and put it inside a container and then deploy it. So today's agenda is going to be how we would take a model, we would take that model, put into a container, and we would want to serve as an API thing. Now, why we are doing it? Because eventually, once we have built these models, or once we have uh, built our models, we would need to package them. And after packaging, we are going to ship it to some kind of mechanism where they can be served. And that is where Kubernetes is going to be helpful for us. So Kubernetes can be used in two cases. One is while you are doing a training of the data. Our data is very small right now, perfectly fine. But when you have a large data, then you need to kind of make sure that you can quickly train the model through Kubernetes. So that is one part there. And second is once we have built the model, we want to deploy them. And for that purpose, we will see that assume that we have a model, how we can deploy them in a container today. And then if time permits, we can try to kind of put them on Kubernetes as well. But yeah, so any idea how we can go about it? I mean, of course, I have the demo ready, but now assuming that right, what we have got, we have played with that Python or that Jupyter notebook thing. We know that we have built our model in that particular notebook. Now, what are the steps we need to follow to make it serve on a container? Any guesses? Anybody want to just tell about it?
A quick question. Which chapter are we doing today? Sorry, I didn't join last week.
Yeah, so that is the case, San Carlos. So we are not following the book as it is right now because
Oh,
we could not follow the kind of say all the labs there because of this open data hub. So that's the thing that we are going to kind of customize a bit. But eventually, once we have understood all the basics, we'll take the chapter from 7, 8 onwards when we can follow it as it is because we can't install the ODH on the cluster. So that we'll do them separately. And then once we understood ML flow, once we understood Airflow, we'll merge them as the book and then we'll do it. That's the plan.
but the chapter I'm reading run to, I think in chapter 3, it says that you can use Minikube. Like
Yeah.
Minikube is not possible to do it with Minikube.
No, the ODH software which they are following, Open Data Hub, that Open Data Hub does not work on Kubernetes anymore. So Open Data Hub
I see.
is
So the book, by the time the book was written, it
yeah.
worked on Minikube, and the latest version doesn't support Minikube, I guess.
No, no, it works only on OpenShift right now.
So
So
it
the
doesn't
Open
support
Data,
Minikube. It only works on OpenShift. Okay.
yes, correct. So now I even tried the OpenShift, but OpenShift did not work very well for me. So that's why I thought of separating it out. And then we discussed earlier also in the call that that's what how we'll do it. We'll understand all the things, and then eventually we'll take that example of what they have in the book from the chapter 8 onwards, kind of a thing.
Okay, yeah, that works out. And if we're doing the work on like small demos and examples, that'll be perfect, right?
Yes, yes,
Yeah,
yeah. Because I think this is the right way of doing it because that book assumed
yeah.
people have
So I
some
can
ML
I can
knowledge.
help. So then I can help because I haven't done OpenShift like in 2 years, so I'm not. But I can help with standard Kubernetes stuff when
Sure,
it gets,
sure,
I
sure. So
guess.
currently, yeah. So yeah. So currently, the question is, assuming that we have built a model, Python-based model, I want to now publish on a container and serve it over an API.
So
What
there's
needs
two
to
answers to that. You want a easy way or like from scratch way. The easy way will be Reserve, right? A framework, which is
Okay.
like too high level, right, for
Not
people to
low
start.
level, basically. We want
But
to
I
go
think
step by step. Yeah.
for learning purposes, and this is, I'm saying this because in practice, like you go to a meeting and that's the answer, but that should not be the answer. The answer should be like, let's start from the bottom, right? Like you
Yeah.
have little Python that you want to run inside a container. It could
Yep.
be a web app, or it could be a web app that there's a calculator, or a web app that uses a Python library with a model, right?
Right. Right.
Yeah. So I think for Python, I think Flask is the web server, good web server
Yep. We should
to
go with
expose
that.
an API, or the Django is the other one.
Yeah.
I've,
Right.
I haven't done web Python, but those are the two I'm familiar with in
Yeah.
Python.
Right. Right. You're right.
The Django and Flask.
Yep. Okay. Okay. So let's go ahead and dive into it. So what I have done is, I know that people may not be familiar with all the Flask and other stuff. So I break down this demo to three parts. So first, I'll quickly give you a
Oh, using
demo of,
Flask. Oh,
yeah.
this was not planned. I didn't know Naveen was going to use it.
Yeah, yeah. No, no, that's how it's going to be. Right? Somehow you have to serve the thing, right? So yeah, that's how it is. So now this is a very simple program, nothing too fancy about it. So what we can do with the Flask? So currently there's no machine learning here. It's just a very simple web app what we are building, and what we are trying to say here is I want to build an app, and on that app, if I give you two inputs A and B, you just return back the addition of that. Simple. So Flask is the interface, or Flask is the libraries available on, or not a library, say it's a framework on Python, right? Through which we can do the web-based stuff, right? So what we have done here is we have simply started imported the Flask program here, and I'll not go too much on that. But what we're doing is we are trying to serve an endpoint on port 8080, and then what we are saying here is expose the root slash. So it can be any root. For example, if you go to a website, Amazon/buy or whatever it is, right? You can expose different services on different endpoints. So what we are saying here, just do it on the slash root only, and then we have a function defined here, which simply takes two inputs. What we will give it as a as an our request, and then it will return kind of addition of that. So let me run it and show it to you. Yeah. So this is the same program of Flask one, which is there on the thing. I would just run it. Right. Yeah. So as you can see that it is now serving on port 8080, which I have changed it here. I can of course keep it default, which is I think 5000, but I just changed it for my convenience. Now once we have done that, what we are saying is if I make a request on the on this particular IP address on this where is it? Yeah, on this particular endpoint, I should be able to, when I send A and B, I'll get the reply back as a addition of that. So for that purpose, what I'll be doing is I'll be using and a kind of a say Postman-like solution, which is Hoopscotch. It's an open source solution. So what I'm doing now is I am kind of making a post request, because in our code we said that expose the post method. So I'm sending the post method here, and I'm putting two variables here. It can be any other variable as well, whatever. And then once I send this data to it, what's going to happen is this particular request came here on the root, where it has got A and B variable. It did addition and reply back to it. That's what I get here. Make sense? Hope everybody is comfortable with this, right? Yeah. Any questions here?
I'm gonna say looks normal. Looks normal.
Yeah, looks normal, right? So the next step is, now what you want to do is eventually is we would want to build our model, and we would build our model and package it such that it can be served by Flask. Hope I'm clear, right? So what I want to do is the way we built the package earlier, the way we built our model previously, we just used some Python code to run the to kind of run the linear regression algorithm to build our model. We got the model earlier, and it was on the notebook itself. Now what I want to do is I just want to take that model and somehow package it, right, which I can serve by the Flask. So what's going to happen is we are going to perform a similar step as the last session, which will go again one by one. But at the end of it, we'll take the model and export it into a format which is called the pickle format, and then we can load the model from the pickle, and then again serve it over the API. So we'll go again step by step. Let's just go to the second step now. Yeah, so this is the second step here. Okay, before I dive into that, just a couple of more information. Yeah. So now what we'll be doing is whenever we have a data set, right, we don't use the entire data set to train the model, right? Because what we need eventually is we want to do the validation as well. So think about, you have done a survey of whatever 10,000 people, and from that survey you want to predict something, right? So the ideally, what we should be doing is we should take part of it, the data to train the model, and then let's say 70%, right? So 70% data we have taken to train the model, 30% we keep it aside. We don't use it, correct? Then once we have trained the model, and we would run that model against that test data, which basically remains 30% of data what we have, and then we can do the validation of it as well, right? Like what was predicted, or let's say, let's kind of go it here, right? So let's say here is my data set which we are building, correct? And now let's say I have 10,000 entries here, and I know with this model I can do a prediction. Now what I'll do is I would take 7,000 entries from this particular data set and train and build my model, which I'm doing in the previous steps. I'm building my model, right? And I am going to have that 30% data which I have left, right? For that 30% data, I'm actually going to have the real values, right? Because that data I have got from some survey or whatever it is, right? Now, once I have built the model, I would basically um, uh, run that model against the test data I have, whatever I left, and then I can check the values, right? What is the predicted value and what is the value which I had in my survey already, and then I can compare them, and that can tell me how good my given model has been trained, right? Hope that makes sense, right? Okay, fine. I assume that does. Okay, so what I have here is um, I have this data set, which is the same data set which you used in the last time. We have the size of the house and the price of the house. So this is the model, or this is the data what we have to train or to build our model. So what I have done here is, yeah. So what we'll be doing is we'll be reading that particular CSV file. Then what I do is I basically um, create this X, capital X variable, which is the size, and then a small y, which is the price of it, right? Then what I do is I'm going to split my data. So as you can see here, right, I'm not going to use the entire data set to do the training of my model. I'm saying it, use this particular library from the scikit, and then create two parts to it, right? One is xtrain and uh, xtrain x test. This is what is x, nothing but part of it, right? Whatever the data I'm going to get from my this thing, right? So I'm going to, let's say I take 5 of the values. So I'm going to take x train as my these 5 values, y train as my these 5 values, right? And then similarly, I'm going to use the remaining part for the sorry, so this is x train and y train and x test and y test. So I am going to take this x, remaining x, whatever I have left with, for the validation of my model, right? That is how it has been done. So we divide our data set into these categories. Then we are going to use the algorithm of linear regression to build our model. So we are doing a fit, right? So we are saying that do this fit of which mean x train and y train. That is going to be my building my model. And once my model is being built, I'm doing a prediction, and I'm just printing all of that stuff right now. So let me run this particular code till here, and then we'll kind of go for the next step after 35
So the
times.
key thing, if I could interject, the key thing here is there's a library called scikit.
Yeah.
And scikit has all these different modules for letting you plug data in, and it will fit the data to a model, or plug in a model and let you plug data in to fit the data to the model. So
these
this is
are,
an example usage of scikit.
yes, correct. So this is the
Okay.
algorithm of the supervised learning. So what eventually happens is, initially the model may not fit rightly to your data what you have, right? So that
Mm-hmm.
linear regression is eventually is going to find the best match with your data what you have right now and try to fit it. That is what is happening in this case.
What does fit means?
So fit means is, let's see here. So let me go back.
Oh wait, I think that you show the
You had
code
a
again.
This
graph. You had a
particular
graph.
graph, right? This particular graph, as you can see here, right? So earlier, I would just have my data. Like if I just plot this data, right, it's going to come like this particular, right? There is no fitting I have done right now. So I just have a regular graph which has the size and the price here, correct? But now, once I do a fit here, what happens is it's going to find out the best possible line, linear line, which can mimic or which can kind of say near to my data set what I have. So for example, if I take the my house size is 500, it can say that okay, your price would be somewhere here. And of course, it is not exactly what you are having right now. So there is a margin of error. The cost we can say it here, which is
I
again
see.
advanced topic of it, but it is trying to fit the best fit with your data, what you have right now available, and the output what you also have right now. So it's kind of finding the best possible match in a way. Make sense?
Yep. Yep.
Yeah. Okay. So that is what this fit particular part is doing here. And so let me just run this code. Yeah, so what you can see here is, I'll kind of quickly go over with my code again. So I have this data which I have loaded. Then I have partitioned into X and Y. That is what X and Y. This X is nothing but your size. Y is the price in thousands of USDs. That is what is X and Y. This I am printing here, right? And then what I did is I did the partitioning here of my data set. So this zero point 0.4 is whatever data set I have, 0.4% to use it for the test purpose. So that is what is happening here. So I've kind of applied this algorithm, linear regression. I have done the fitting of my model as well. Now, once this model is been fitted, this LR has been fitted. What I'm doing is I'm now saying is take this X data set, test data set. So basically, remaining data set which I have left here, right? Whatever I have left here, take that and do a prediction of the prices, right? So it is telling me that pricing of the test data set is this one, correct?
I see.
Just a quick
Yep.
question.
Very
Yeah.
nice.
Just a quick question. The objective of the LR fit is to yank out any outliers, right, while it's creating the linear model, correct? So
It's not to
is
just
it,
no, it's based that you should taken care into data analysis part per se. If there is an outlier, if you bring outliers here, the regression would not work as expected. So, for example, if you have some data set here, which is let's say $100,000 or whatever, right? Some houses more than that, right? That
Yeah.
would go out of this particular graph itself, and then it's very difficult to fit it, correct? So if you have an outlier or something which is so then you can take logarithmic um, regression, something like that, that can help us in those scenarios. So this particular graph has created easily because our data set is very small. and it is not having much of variation there. But if you bring a lot of variation, then this particular uh, line would not be able to cater to most of the points here. So, for example, if one of a point is here, okay, so one more thing we discussed last time, that how much distance you have between the actual value and from this line, right? That is an error, correct? So think about if you have one point here, the error would increase, which means your performance of the model is decreased in a way, correct? So a fit does not mean you want to get outlier out. It just means that at this point of time, if you try to ask me to fit, I will give you the best possible line. But if there's a lot of difference, then it's difficult for me to take the right line, and then I may get a lot of errors. So that is another. I think that's an ML concept which is there. I hope it makes
Right.
sense.
If the data is just too wild and you can't fit a linear regression, then maybe you try a
Different model.
nonlinear regression
Yes,
of one
correct.
sort
You
or
do a
another.
different one. Correct. Yeah, that's what.
Yeah.
That's the whole
Yeah.
idea. So again, that's a complete ML field, which I think I'm kind of a newbie there, and you can explore more on that. But from the perspective of the ML ops and ML on Kubernetes, like we know that if you have a model, how you want to deploy them, correct? And going too much of ML, we can do, but it's not the purpose of, I believe, this
Yeah.
particular session. Yeah.
Someone told us they use linear regression. Okay, here's the data. Okay, use Kubernetes to do training and see if and do predictions and do the test and do the validation. And you say, yes, sir. I trust you. I trust you. You clean up the data before you gave me the data to use.
Yeah, so if you look at this is the in the entire cycle, ML is a very small part, right? And other things are very important as well, right? So so ML is done by the ML. So there are different. We discussed all this thing earlier as well. We have different personas. They've got different things. So we are not a persona who is looking into
No.
building a model. We're the persona who is trying to see how we can train and serve the model. Correct. So that is where we are looking
Yeah,
this
training and
particular.
serving. Yeah,
Yes.
as most efficient possible, as most costly efficient possible,
Yes.
right?
Hmm. Hmm.
And fast as possible,
Yeah,
right?
because
And
that's our
secure.
correct.
A
That's
lot of
our
work, right? No, you have a lot of work, like to just add something else to worry about, like if the data scientists are or the scientists are using the right model or not.
yeah. That problem is I think for them, not for us. So given that they have given us the model, we need to see how we can put them in production, and then make it serve right, and then of course provide them stuff for them to run the training stuff. So choosing the right model is the thing what data science team would do. Yeah. Okay. Anyway, so let's come back to our stuff. Okay, so what we have the output here is from this particular thing that okay, once I have did the model fitting, I am predicting the values from my test data set X test, and then I'll get some Y test output, right? Or no, not Y test. I get a prediction. I get the prediction output, and this prediction I should be able to match it with my Y test. And if they are matching, it tells me how good my model is. That is what the score is mentioning here. As you can see, it's LL underscore that tells you what is the current effectiveness of my model. So because out of just 9 entries, right? I'm saying do a training as well, do a validation as well, and in the same 9 entries, it's not a good anyway, right? But given that if you have filtered the right values, you can play around with this particular effectiveness. So for example, if I say I'm going to pick up, let's say 0.7 as my test size, right? Which means I'll have, let me run this again. And you can see now my performance of my model has gone from 0.69 to 64 because I have just given two of the inputs to test, correct? Right, as you can test size is point, 0.7. So test is nothing but which I'm giving for testing purpose, which means zero point 0.3 is I'm giving only for training purpose. So out of 9, I'm saying take only 0.3% of data for training purpose and remaining for testing purpose. And that is why we see this particular prediction here for 6 numbers here, kind of a thing, right? And based on this, our effectiveness would vary, as you can see here. So again, that is something which has to be taken into account by the data science team, but that's okay. Okay, so that what that is being done. What I'm doing next is I am just trying to create one random value, which is we can just ignore. This is one sample value. Now the next thing comes up. We have got a model which we have built. Now we are going to package the model, and for that purpose, we are going to use something called as pickle module from Python. So what we are going to do is now we are going to pick up our so if you look at here, this is LR is our kind of a model what we have built. So what we are saying now is uh, create a file called lr.pkl in my current folder, write as a binary, correct, and then pickle dump. So I'm saying that this particular LR is my model and dump into this particular file. That is what I'm saying here. So let me remove that file from my current folder. If I have lr.pkl. So I'll remove this file. It's not there anymore, right? Let me, I think, go back and change the test size to 0.7, 0.6, whatever was. Okay, let's say 0.4 only. Okay, so I'm just going to now run this program again. Now our model would have been built. As you can see, this is already built here. This was just done in the last this step right now, correct? So what I do is I basically package my model into a file. And now in the next step, what I'm doing is I'm trying to load my model from that same file and doing a prediction based on that model which I have loaded from that file. So I'm not using the previous one, but what I'm doing is I'm trying to load a model back into my memory, and then I'll do a prediction of whatever the number of the house size I'm looking for. Correct? That is the number what I'm getting at the end here. So one sample prediction from the load module. Correct? Hope it makes sense. So you basically
Well,
play around.
could I ask? Could I
Yeah.
ask how
Interesting.
how big is the pickle file? I mean, it's got to be small. It's got to be like two numbers, right?
Yeah, it
The
was very small,
linear
right?
regression can only be as two parameters, right?
Yeah, it's very small, right? It's some bytes are there.
429 bytes.
Yeah, very light, very small. So of
Okay,
course,
so
But
depending
small.
on the this is
Okay.
but
based on your
sorry for
data set, it
interruption.
would change, right? Of course, don't it will not be so small. Based on your data, it's going to change, right?
Yeah.
Yeah, but the interesting is that you have the what is something a function that you have in Python. You have already a binary that can reproduce that. I know that maybe it doesn't fit what the business case that we try to solve. That is the price of the house. But at the end, you have something that you can portable. It's portable to a Docker or whatever.
Yep.
That's the interesting part of this
Yep.
of this idea
Yeah,
that you
Pico is
can.
a Pico is a popular format file of packaging models, and there's other formats in the industry, but Pico is one that comes up a lot, and it's a very basic one, right, to get started.
Yep.
So I bet if you put predict 2200, you should get the same number, right? Instead
Yeah,
of 400.
we can do that. Yeah.
And one clarification I wanted to go to say at the top when you say the effectiveness, right? That number changing to 6.9 to 6.4 is not. It's both the test data that you're doing. If you have good test data, and how much test data do you have, but also like the most important in here is like how good is the model matching the data, or how much
Yes.
quantity of
Both
data
things.
you have will make the model more effective. It's like the effectiveness, like, is did you guess correctly with this amount of data and the linear model.
Correct.
And the test data could be in the same file, could be a different test data, right?
Yes. Correct.
But the effectiveness
So
is like the one magic number that you can do in continuously CI/CD pipelines, that you continuously like run this until effectiveness hits 90% or 95. And then when next week, then you get another dump of data and a maybe improved model, you can run through the CI/CD pipeline, MLOps, and then if it drops from 90% to 80%, you stop the pipeline. You open a defect, you send something to Slack saying we cannot ship this into production,
Hmm.
this model,
correct.
because it went from 90% being effective to being 80% effective. And that's kind of like the domain of like what is being hot right now. And that's actually one of the And also comparing models. Like you have two models that you're comparing, which one is better to predict house prices, right? It could be a linear model versus another model
Yep.
or a third party.
Correct.
But that's the aspect of like machine learning aspect. And like this is like the most simple, short example possible that I have seen
Yeah.
of
I get
explaining
that.
this, right?
But there is another reality underneath of that, that maybe the model could be very efficient during a week because somehow the data and the way that has been training,
Yep.
it works for the reality for a week, but something unexpected could happen and the model is not working
Yeah.
anymore because have changed something. We all have lived the coronavirus situation, so any model that
Yep.
you have before that, and it's something that is explaining in the book that that for me makes sense to provisioning in a more efficient way the model in order that you can train it. So create a kind of platform and around of of the idea of training the model and even serving the model the most efficient possible in order to be ready for any change of the reality that you try to predict because it could
Yeah.
change
So
from one week
overfitting,
to
all
another.
those things happen. So it's continuation. You have to check with the
Yeah, continuously check.
with
That's
the
you don't
with
ship a model into production if it doesn't meet the criteria, right?
yep.
And like you said, it can change the criteria that the model or the data changes, and even the test data, right? So the test data, if you want to go to reality use cases, right? Housing pricing, you will not have the housing pricing hard coded into a file. You will go overnight and find all the house pricings that are new, right? That change. All those prices change every day, and that's your test data that then you
Yes.
run through the CI/CD pipeline daily with live data to see if the model is like predicting. It predicted this price, but then 2 days ago wasn't that price. The model is not actually working. The effectiveness is not working because using the correct test data.
Yeah, with test data, and of course, the features would change also, right? Because that's the whole idea, right? Like, let's say, I mean, something like, say, a school has coming up, or somebody, let's say, government decided to kind of build airport near to the other locality, right? Suddenly, the price will go up there. So that is changed. That feature is changed, right? So,
Yeah,
not,
and time like my brother is in real estate, and he tells me like people always put their houses on sale around January and February because they think about it in December when they're like not busy with work and everything like that. They start thinking about future plans and like they have more time to think about things. So that's where like people put their houses on sale on January, February, right? And then that affects prices.
yeah.
So I don't know. I don't know anything about real estate,
So
so
that's
don't take my
no, no.
advice.
Okay. So let's continue. So now, assuming that now we have got a model package, right? So now we'll try to merge that Flask and this together, right? So now that's the next step is that what we'll do is again the remaining stuff what we know already, right? We have the Flask stuff. We have now a slash predict endpoint, and what we are doing is before we run anything, we are loading our model in this particular Flask, whatever the program of Python we are building. So we load the model into this model variable, and then what we now do is we are going to um, expose this thing on the slash predict endpoint, and the same stuff, right? We'll make now a query of a given size, and then we do this prediction of the from the model for the given size. That's it, and return back the reply. Pretty straightforward, right? Any questions on this Python file?
No, like I think if you are in this space, um, learning that this is what it takes, the building blocks is crucial because sometimes you will see a lot of like frameworks and products and like very advanced things, but they start from this, right? Taking a model, packaging it into a container, downloading it, and then serving it.
Okay. Yeah. So now we
And as you
have
saw,
got
it's like 10 lines. It's less than 10 lines or something like that.
yeah,
Like,
it's very small.
yeah.
Yeah. So now this is serving on this particular endpoint, right? So now what I can do is I can go to the same endpoint and then I'll say slash predict here. That's the endpoint which I have. And now I have the variable name which I have, I think S there. Yeah, it says S, right? Which is what I'm requesting from the form, right? That one. So I'll say S is equal to of a given square feet, right? Whatever. And send it. And I get my reply back. Correct? Make sense?
Yep.
That is how it is working.
Yeah. So this works as your hello world, right?
Yeah. Hello. Yes.
At scale, that's where like SaaS products and cloud products and vendor products and big frameworks come into play, right? And the scalability of running this in production. But it
Okay.
starts from this simple 10 lines of code.
Okay, so the next step is how we can put in a container. You would have already guessed it. So we'll put in a Docker file, and this Docker file is pretty straightforward to read per se, right? So we are using this particular base image. We create a directory. We copy all the content in that, put it on port 8080, work there, whatever it is. I think it's pretty straightforward. And whatever the modules we need, we'll put up in that particular requirements.txt file, and then just run this program, right? So let's build the image, and then put on a container, right? So let's just do that. So build, yeah, Docker image build -t. Let's say lr. Let's say we'll give a demo. This one. So you will perform all the steps what is mentioned there,
And you
and
run Docker image to see the size
yeah,
of this image?
base image is too much, but we can see that. So because of that, this Python image is too heavy. That is why it is 3.5 GB.
See, this is what I wanted to show. We have a Pico file, 400 bytes. Like now we suddenly have a 4 gig image that we have to pull down from my container registry and pay for it.
This is because only of this image, nothing much.
But
This
that's what I'm
can
trying to say. It
definitely
doesn't matter if it's that image or not. Like there's images that
no
are
no
like
no
that.
no. In our case, this can be very less, correct? Because we picked up the wrong image, base image. That's why the size is so much. But
So
otherwise, it
Anaconda
cannot be.
is a development environment.
Yeah, yeah.
It's
That
got
is
everything
why.
in Python for doing
Correct.
development.
That is why. Because
Yep.
otherwise this would be very less size. So that would the size of this image will increase only if the model is heavy. Otherwise, nothing. You can just use a simple Python here, and this would be in KBs only, or maybe some MBs, whatever. Correct.
Yep. Yep. Yeah, I just
So
wanted to show like choosing the wrong image, right? Or
yeah, of course,
using
that
the
is
dev
fine.
image in production affects the product affects production, right?
Yeah, of course, that would be there. Okay. Anyway, so our image is being built now. Sorry.
But any reason you use Anaconda, this image,
No, no, some
instead of
examples
using
are
Python?
following through, and that's why I just did it. Nothing else.
Okay, okay.
Yeah, yeah. Because as you,
You use Anaconda if you're doing like Jupyter notebooks and
yeah,
things,
yeah,
and
correct.
so
Yeah.
it's when you're doing Python development.
Yep, yep.
Yeah.
Yeah. Anyway, so now let's try to build an image. So Docker run the image. Image is already been built. So Docker container run -p 8080 colon 8080, and then the image lr.demo. So image the container is running now, and now we can run the same test again. Now this I believe all of you know, right? If we are hitting this port on the host, we are going to this port on the container, right? And again the reply whatever we had that thing, right? It should also work as it is. So now we
Is
saw
Hopscotch better than Postman? Should
it's
I
an
be
open
using
source
Hopscotch?
solution. It's an open source solution. You can use it. It's personal choice there. That's okay. Doesn't matter.
Okay.
You can give it a shot. Yeah. So
Okay.
yeah. So now what we have done today is right. We have taken the base a model. So basically, we first trained our model, exported a model, and then we import the model and saw the value from it. Then we also covered how we can export with a Flask simple Flask program, and then we also how we can containerize it and start shipping it to the container. And of course, this can go in Kubernetes as well. Doesn't make much of a difference. But of course, for production, there is more things required. Like you should be not using Flask, use some better and all those stuff. But this is still a good start, I believe.
You can use the Docker history command to just check the size by layer. I think that will show like the base layer is.
The base layer, I know it's size, right? I know the base layer is this because I know that.
Yeah.
That's fine. Yeah, that is
Yeah.
fine. That is the okay.
We're running out of time. Could you possibly put a pointer to your GitHub repository that you were drawing from?
No, this data I don't have it. I'll put it there in a Git repo and share it.
Ah,
So
okay, thank you.
this data is not there yet. And Francisco also working on some other examples. So I showed the example of regression model. Francisco would, I believe, show with classification next time. So it's like
Yeah.
change this particular program to classify some stuff.
Oh,
So
interesting.
instead of regression, we'll use classification next time. So that is a final. It's the same built on this, and then we can show one more example, and then we'll go to the next step.
I mean, you continue with the different kinds of the regressions and classifications, and then at some point you could stick Olama in here or open
Yeah, that's
API
correct.
or open AI APIs in here.
Everything can be done.
It's the same format. The same.
Everything can be done. Yeah. So once you understood
Yeah.
this concept, so the next part for us is, of course, to kind of explore we have built our model, we've containerized it as well. Now we will need to see that how we can run it or make it as an MLOps thing, right? That is where I believe we'll be exploring ML flow or Q flow. I think we'll do with the ML flow for now because that's what book is there. So what we should be doing is eventually is, so this model is being built currently with the data just static or not static per se, but of course we are making an API call and getting data. And of course, what we challenge we discussed earlier, right? That some things can change, right? Our model can start not behaving correctly.
Yep.
Our customer kind of saying that, okay, now this doesn't make sense to me, and all those kind of things, right? So we do a regular building of the new model, the new feature set, and all that stuff, right? So we'll see that how we can build that MLOps pipeline. So I think ML flow is going to play a role in that. So that is one part of it, that ML flow we kind of want to explore from the next time, and then see whatever we have done, how we'll kind of fit it there, and then take it forward from there. So again, I have not explored ML flow at all at this point of time, but I believe that's the next logical step. And
Yeah, I like
So, are
it.
you going to follow the classification folder in the ML demos repository?
I don't think so.
Okay.
It's again that can be, and whatever example Francisco would choose, because we're not bothered too much about learning ML per se here, right?
Yeah,
We're
yeah.
bothering about that. Okay, once the model is being built, what next? Or how do we fit in that,
Okay.
put into the entire pipeline
Yeah,
of CI/CD and all that stuff,
I
right?
agree.
Because going into ML is just going to be way too much of this particular audience, and
Okay.
of course, it's too much for anybody else as well. Yeah.
Yeah, I agree. And also like dealing with models like embedding the model in the container or pulling down the model like from Hugging Face, right? And those aspects are like more operations aspect versus like going down into the science, I guess.
Yeah. And so
Which
we'll try to
people
cover
might
the
say that
basic.
Kubernetes is a science, but it's not.
Yeah, so we'll try to cover the workflow from our perspective, right? Assuming that model is being given to us, how we'll
Yep.
put in the pipeline CIC, that's one part, and then see
Okay.
if we can cover some training part as well. That if we are given some large data set for training, how would I put that workload on Kubernetes to do a fast training? Correct.
Yep. Somebody
That is
gives
what.
you a 1 terabyte training data.
Uh,
Run it, right? How
right.
do you do that in Kubernetes?
Or cats and dogs. 10,000 images of cats, 10,000 images of
Yep.
dogs.
Yep. And they're located in object storage, I say, right?
Yeah.
Somewhere.
Right.
Yeah, we'll see what you come up with for next week. Thank you very much.
Yeah, thank you so much.
Yeah. Okay.
Thank you.
I mean, I appreciate if all of you also kind of go and explore ML flow a bit. That would be.
Yeah, MFO is popular, at least I can say from end users I work with in production. So MFO is also popular among other some end users are in production.
Yeah.
So
Okay.
good choice.
Okay, guys. See you. Hope it was useful. Yeah.
Okay, good.
See you next week, guys. Bye.
Thank you.
Thank you.
Thank you.